Welcome everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. The present lecture, this is lecture number 9. The topic is regression and this is a part 1 of this topic. The subject is biostatistics and research methodology. The code is BP 801T and the course is Bachelor in Pharmacy and university is Dr. APJ Abdul Kalam Technical University. So, first we start regression. Regression analysis. Regression is a statistical procedure that determines the equation for the straight line that fits a specific set of data. So, regression is a technique concerned with predicting some variable by knowing other variable, or in simple words we can say we can predict a variable, unknown variable with the help of known variable. So, regression is a process of predicting variable y using variable x, and it is necessary in regression there should be a correlation between known variable and unknown variable, and the variable which we want to predict, that is y, is called dependent variable, and the known variable which is x is known as independent variable. So, with the help of regression we can predict the value of unknown variable with the help of known variable. It tells us how values in y changes as a function of change in values of x, that as the value of independent value are changes. So, what will be the change in the dependent value we can calculate with the help of regression. Regression. So, regression generally relate to correlation, but it has a difference between the correlation and regression. In the term of prediction, correlation does not help in making prediction, while regression enable us to make predictions using regression line. So, in correlation we cannot predict any value of dependent variable with the help of known variable, but in regression we can predict the value of unknown variable with the help of known variable. For example, if we have a relationship between height and age. So, if we know the person of age, we can predict the value of the height for that person. In the terms of symmetry, there is another difference between the correlation and regression. The correlation coefficient are symmetrical, that is if we have a correlation r x y, that means the correlation coefficient of x on y and the correlation coefficient of y on x r y x are same. That means, if we calculate the correlation coefficient y on x and the correlation coefficient x on y, we get both are equal, while in the terms of regression the regression coefficients are not symmetrical. That is, if we find a regression coefficient b x y, that is regression coefficient of x on y, it is not equal to the b y x, that is regression coefficient of y on x. So, in the terms of symmetry, correlation coefficients are symmetrical, while the regression coefficients are not symmetrical. And in the terms of origin and scale, correlation is independent of the change of origin and scale. that means, if we change the scale of the variable or the origin, the correlation is independent. That means, then there will be no change in the correlation coefficient, while in the terms of regression coefficient is independent of change of origin, but not scale. If we change the scale, measurement scale like ratio scale or ordinate scale, the regression coefficient will be changed. So, these are the main three differences between the regression and correlation. The regression can be defined with the help of regression equation mathematically, and there are two important terms in regression equation: intercept and slope. As we know, the regression equation define the line of equation, and we have read earlier the equation of line is equal to y is equal to m x plus c. So, similarly, here the regression equation is y hat equal to a plus b x. Y hat is the predicted value of a, y hat is the predicted value of regression, that is y, and a is the intercept plus b is the slope and x is the dependent variable. So, here in y hat a equal to a plus b x, x is the independent variable and y is the dependent variable which we want to predict. So, this is the main equation for regression. Now, to find the regression, we should have the value of a and b. The value of a and b calculate by different method. First is so how we find the best regression line? The distance of the points from the line are equal to the residuals, and our aim is minimize the sum of square of the residuals. So, this is called least regression line. If you see in this figure, we have two variables. One variable is percentage receiving reduced free school lunch. It is the percentage receiving free school lunch. Here is a one variable and this is independent variable, and be remember in the regression we take independent variable on x axis, while the another variable is y helmet use rate in terms of percentage, and y is the dependent variable which we want to predict, and this is a scatter diagram we see in the picture. Okay. And these are the scatter diagram, and the blue line is the line of regression. These dotted distance between the line and the point is called residuals, and the best line which is most of points lie on the line. So, our aim to get the best regression line, we want to minimize these distances, and this is called best fit line. To calculate the best fit line for a certain set of data, we would minimize the these distances, and the regression line makes the sum of the squares of the residual smaller than for the other, as if we draw many line from these points, some line will pass through this point or some will lie point this point, these also the line of equation equation line, but all are not regression line. The regression line which is line which have minimum residuals, this is the regression line have minimum residuals, or you can say the minimum distance between the points and the line. So, our aim is to in regression the best fit line for which the distance are minimum. Now, we find mathematically the regression equation by the curve fitting by least square method. What is the curve fitting? Curve fitting is the minimize the distances between the line. By using the least square method, a procedure that minimize the vertical deviation of plotted points surrounding a straight line. In least square method, it is a procedure that minimize the vertical deviation of plotted points surrounding a straight line. We are able to construct a best fitted straight line to the scatter diagram points and then formulate a regression equation in the form of y hat equal to a plus b x, and it can be written as y hat equal to y bar plus b x minus x bar, where y bar is the mean of the y values and x bar is the mean of x variable values, and b is the regression coefficient. And this regression coefficient of y on x is calculated by summation x y minus summation x summation into summation y upon n upon summation x square minus summation x whole square upon n. So, here summation x y is the sum of the product of the values of x and y, and in the here summation x into summation y, here we first sum of the x values and then find the sum, and it multiplied by the y values y variable values sum with this, and here n is the number of observation in our sample. Summation x square represent we first square the x values x variable values, then find the sum. Summation x square is the sum of the x square, that means we first square the x values then find the sum, while in here if you see summation x whole square, summation x whole square means we first sum the x values x variable values and then square the term, and n is same number of observation. So, these method to find the regression coefficient. To understand this, we take a example, a sample of 6 person was selected, the value of their age, x variable and the weight is demonstrated in the following table. Here we have in our example 6 persons and the variable are 2, age and weight, and as we know weight is depend on age. Okay. So, we take weight as a dependent variable, and as we know age is independent variable. So, age we take age as x and weight as y. So, these are the values given in the example. The person whose age is 7 years and the weight is 12 kilogram, and the person whose age is 6, the weight is 8 kilogram, and the person having age 8, weight is 12 years, and the the person whose age is 5 years, the weight is 10 kilogram, and for the 6 year age the weight is 11 kilogram, and for the age 9 years the weight is 13 kilogram. So, in this example we want to find a regression equation for the weight on x. That means, we want to find the equation of y on x or weight on x. X is age. So, first our aim is to find the regression equation of weight on age. Weight is dependent variable, age is independent variable, and second problem in this, we want to predict the weight when age is 8.5 years. So, first of all we find the regression equation in this equation example, then we want to predict the weight with the help of that equation, what will be the weight if age is 8.5 years. So, there are two problems in this example. First we want to find the regression equation, and second we want to predict the value of weight with the help of the equation if age is 8.5 years. This is the first of all we draw a table, and in which age we write the age and we take as it as x. Why we take it as x? Because it is independent variable, and as you know independent variable or known variable we take x. This is 7, 6, 8, 5, 6, 9, and then we find the sum of x. The sum of x equal to 6 plus 7, 13 plus 8, 21, 5, 26, 26 plus 6, 32 plus 9 equal to 41, and this will be equal to summation x. This is called summation x. Now, similarly we write the values of y and find the sum of these y values 8, 2, 10, 2, 12, 1, 13, 3, 16, 16, first 6, then we carry 1, 1, 2, 1, 3, 4, 5, 6. So, this will be equal to 66, and this is the value of summation y. So, summation x equal to summation x equal to 41, summation y equal to 66. Now, we find x square. In x square we find squaring the values of x, 7 7 ja 49, 6 6 ja 36, 8 8 ja 64, and then we find the sum of these nums. This will be equal to summation x square, and similarly we find the value of y square. We squaring the values of y, 12 12 ja 144, 8 8 ja 64, 12 12 ja again 144, 10 10 ja 100, and we find the sum of these terms, summation y square, and in the next column we find x y. X y is the product of value of x and y, 7 into 12 84, 6 into 8 48. So, and add these terms, and this will be equal to summation x y. So, we get the value of summation x, summation y, summation x square, and so on. Now, we first calculate the mean. Mean equal to x bar. X bar equal to summation x upon n. Summation x upon n. Summation x is 41 upon 6. Similarly, we find y bar, summation y upon n, n is 6, summation y is 66 upon 6. So, it will be equal to 11, and this is 6 6 ja 36, 6.8 something. So, first of all we find the mean x bar and y bar, that is here. So, x bar equal to 6.83 and y bar equal to 11. Now, we calculate the regression coefficient, this we known as b equal to summation x square minus summation x y summation x into summation y upon n summation x square minus summation x whole square upon n. So, we have the value of summation x y is 461 minus 41 into 66 divided by 6 and the summation x square is 291 minus summation x is 41. So, we square the 41 square, we remember here we squaring the value of summation x. So, we square the 41 divided by 6. On solving this we get the regression coefficient b equal to 0.92 and the line of regression we know y hat equal to y bar plus b into x minus x bar. The regression coefficient equation formula is y hat equal to y bar plus b x minus x bar. So, we put the value of y bar is 11, b is the regression coefficient, we put it 0.92 and the x bar is 6.83. On putting the value we find the y hat equation between y and x. So, y hat equal to the main equation is this is our required regression equation. On solving the previous equation y hat equal to 4.675 plus 0.92 x, where 4.675 is the intercept and 0.92 is the regression coefficient. So, this is the required line of regression. Now, so this is our first answer and the second problem in our example we want to predict the value of y if the age is 8.5 years. So, to find the value of weight when age is 8.5. So, in the regression equation, this is the regression equation of weight on age. I again tell you, or you simple words you can say this is a regression equation of y on x. Now, we want to predict the value of weight when x is 8.5 or 8.5 years. So, we put the value of x here 8.5, on multiplying solving this we get the weight is 12.50 kilogram. So, you see here that if we have any value of age we can predict the value of the weight. So, this is the main application of the regression. Regression generally used for, I have already told you in the earlier, regression is used for the prediction of a unknown variable with the help of known variable. For example, if we have a skeleton and we have a regression equation between the age and gender and skull circumference. So, if we have a skull and measure the skull circumference, we can predict the gender of that person or we can predict the age of that person. This is the main use of the regression. Now, the another thing is if we have another, for example, we have age x equal to 7.5 years, then we can predict the value of weight for this data y equal to y had 4.675 plus 0.92 into 7.5. On solving this we get the value is 11.58. Now, I want to explain one more important point. If we find the difference between these two weights, that is 12.50 upon 11.58 and find the difference 290 point, and this will be equal to the regression coefficient. This value is equal to the regression coefficient. So, here I can say that कि अगर हम किसी पर्सन की एज में 1 ईयर का इंक्रीमेंट करते हैं, 7.5 ईयर से 8.5 ईयर्स का इंक्रीमेंट करते हैं, तो उसके वेट में जो इंक्रीमेंट होगा वो रिग्रेशन कोफिशिएंट के बराबर होगा. तो रिग्रेशन कोफिशिएंट हमें बताता है कि x की वैल्यू में 1 का इंक्रीमेंट करने पर y की वैल्यू में कितना इंक्रीमेंट होगा. दिस इज द मेन इंटरप्रिटेशन ऑफ द रिग्रेशन कोफिशिएंट. एज यू हियर सी, when age is increased from 7.5 years to 8.5 years, the increase in weight 7.5 to this year equal to 0.92 kilogram, and this will be equal to the regression coefficient of our equation. So, we can create a regression line with the help of these 2 points, any 2 values of x and y like this. Here weight, weight is this and age in years, and we can find that this is the line. This is the regression equation line. We also predict the another regression equation 59 points for a grades in class and the number of hours study per week. So, we have another regression equation. With the help of this regression equation, if we have the number of studying hours for someone is 12 hours, then we predict the final grade equal to 97.99. Thank you.